Hello and welcome to Neo-Psychology with me, your teacher, Mr. Neo, the channel where I teach you psychology lessons to my lovely students. Today we're continuing with Biopsychology. We're having a look at Lesson 5, Hemispheric Lateralisation and Split Brain Research. That's a mouthful. Love it. What is that? Let's find out, right? Starter. What are some stereotypes of the left and right side of the brain? So we've got the left and the right hemisphere. What are some of the stereotypes of the left and right side of the brain? And do you agree with them? Do you agree with some of these stereotypes that you hear of in everyday life? Let's have a look at what this lesson entails. So we've got two learning objectives today. We've got show comprehension and apply knowledge of hemispheric lateralisation, and to identify and analyse split brain studies. Interesting. Learning objective 1. Let's get started. Show comprehension and apply knowledge of hemispheric lateralisation. Here we go. Neuroscientists are interested in whether certain activities and behaviours are controlled or dominated by one hemisphere rather than the other, known as lateralisation, as distinct from localisation. Localisation is looking at specific parts of the brain and what actions they do. This is similar, but it's more broad. It's talking about lateralisation, right? How one whole side is determining the behaviour or the physical or psychological ways of a certain person. Broadly speaking, the right hemisphere controls activity on the left side of the body, and vice versa. The left hemisphere controls activity on the right side of the body. Right? Anything to the left or to the right of the nose is what's known as the left or right side of the body. Today we discuss this question with the help of some groundbreaking experiments involving so-called split brain patients. Hemispheric lateralisation. As we have already seen, the ability to produce and understand language for most people is controlled by the left hemisphere, right? So in the picture I've got there, the brain is facing forward, so the left-hand side is the left hemisphere. This suggests that for the majority of us, language is subject to hemispheric lateralisation, right? It's focused in one hemisphere. In other words, the specialized areas associated with language are found in one of the brain's hemispheres rather than both, right? So language specifically is one that is usually found in the left hemisphere only. The question of whether other neural processes may be organized in this way was investigated in a series of ingenious experiments conducted by Roger Sperry and his colleagues, known as split brain research, for which Sperry was awarded the Nobel Prize in 1981. So this guy got a Nobel Prize for this piece of research, right? Let's find out a bit more about it. What did this guy Sperry do? Me and my mate Roger. In 1861, Paul Broca established that damage in a particular area of the brain of the left brain hemisphere led to language deficits. Yet damage to the same area of the right hemisphere did not have the same consequences. However, this raises an important question. If language is located in the left hemisphere, how can we talk about things that are experienced in the right hemisphere, like facial recognition, right? So facial recognition is in the right hemisphere, okay? And everything we understand about facial recognition is in the right. But how can we talk about facial recognition, talking about people's faces, if it's in this side, if talking is in this side? This is what we're going to wonder about. The answer is that the two hemispheres are connected. Our left and right hemisphere are connected together. It's a brain, right? They're connected together. There's bits of it that are connected together. This allows information received by one hemisphere to be sent to the other hemisphere through connecting bundles of nerve fibers such as the corpus callosum. So the corpus callosum is the name of the nerves that connect the left side and the right side. If you see from the image with the bit on the left, you can see the majority of the brain is actually split, but there is a bit in between that is connecting, which is called the corpus callosum. There are other nerve fibers as well, but the corpus callosum is the main nerve fiber area which connects the two sides of the brain. The chance to investigate the different abilities of the two hemispheres came about when, in a treatment for severe epilepsy, surgeons actually cut the bundle of nerves that formed the corpus callosum. So what they were doing was they actually split the brain. The aim of this procedure was to prevent the violent electrical activity that accompanied epileptic seizures crossing from one hemisphere to another. Patients who underwent this form of surgery are often referred to as split brain patients because they physically cut the brain in two now. So there's two, and they cut the corpus callosum, so the bit that connected the two brains is now been cut. So they are split brain patients. And they did this to reduce the epileptic seizures. It's only in absolutely severe cases where the individuals with epilepsy probably would die from it if this hadn't been done. And otherwise, there will be other ways in which to manage it. Not everyone with epilepsy has a split brain or has gone through a procedure of split brain. Hemispheric lateralisation. We've got a gap fill. Let's try and fill the gaps. Let's get the definition sorted. The idea that the two halves, also known as hemispheres, of the brain are functionally different and that certain mental processes and behaviours are mainly controlled by one hemisphere rather than the other, as in the example of language, which is localized as well as lateralized. It's on the left. Right, hemispheric lateralization, the idea that the two halves or hemispheres of the brain are functionally different and that certain mental processes and behaviors are mainly controlled by one hemisphere rather than the other, as in the example of language, which is localized as well as lateralized. And that's hemispheric lateralization. Identify one thing you learned about hemispheric lateralization. Why do you think learning about hemispheric lateralization is important? And how does it apply in real life? How does this help us in everyday life, right? How might this help us in everyday life? How does this help us with our understanding of the human brain? You got, it's really interesting that we understand that there's hemispheric lateralization. I didn't know that there were two halves of the brain and they were actually quite separate in some cases. I understand now that those individuals with epilepsy have a split brain. We're going to find out a bit more about that. What questions has hemispheric lateralization raised for you? What questions have you got? Are you still wondering about, right? Write them down, put them in the comments, let me know. And there we go. That's learning objective 1. Show comprehension and apply knowledge of hemispheric lateralization. I'm ticking it off. Cha-ching! Now we're moving on to learning objective 2. Identify and analyze split brain studies. So this is studies using split brain patients. Let's have a look at split brain studies then. Sperry's 1968 studies involved a unique group of individuals, all of whom had undergone the same surgical procedure, an operation called commissurotomy, in which the corpus callosum and other tissues which connected the two hemispheres were cut down the middle in order to separate the two hemispheres to control frequent and severe epileptic seizures in the most severe of cases. This meant that for split brain patients, the main communication line between the two hemispheres was removed. This allowed Sperry and his colleagues to see the extent to which two hemispheres were specialized for certain functions and whether the hemispheres performed tasks independently or of one another. So, because the two hemispheres, the left and the right, cannot communicate anymore because they've physically been separated from each other, how will they perform certain tasks? Will they continue to perform the task independently, or will there be some issues? So they separated. Procedure. So this is the procedure of Sperry. Sperry devised a general procedure in which an image or word could be projected to a patient's right visual field, processed by the left hemisphere, or the same or different image could be projected to the left visual field, processed by the right hemisphere. In the normal brain, the corpus callosum, which is the connection between the left and right hemisphere, would immediately share the information between both hemispheres, giving a complete picture of the visual world. However, presenting the image to one hemisphere of a split brain patient meant that the information could not be conveyed from that hemisphere to the other. So, I made a brilliant presentation to show what this means. So we got the left hemisphere and the right hemisphere. The doctor says to them, "What do you see?" And the ball is in the left visual field. This is of a normal patient. So this is what the left hemisphere might say. "Hey, right hemisphere, I can't see anything because the object is on the left of the nose, in the left side. What can you see?" "Yo, left hemisphere, you're in charge of language. Tell the doctor I can see the ball." "We can see a ball, doctor." Brilliant. Now we got another. Now this is a split brain patient. The knife comes in, it splits the two. And the brain has been split now. "What do you see?" "I can't see anything," says the right hemisphere, "or communicate with the left, because the ball is in the right hemisphere, so the left hemisphere can see it, and he can't communicate." "Well, I can see the ball," says the left hemisphere, "and I have the language abilities, because the language abilities are in the left hemisphere, so I'll respond. I can see a ball, doc." Now the ball is in the left hemisphere, and this is a split brain patient. What happens now? What do you reckon? What do you see? "I can see the ball," says the right hemisphere, "but I can't tell left hemisphere what I can see because I can't communicate with it, and I can't tell the doctor because I don't have the ability of language. The ability of language is in the left hemisphere." "I can't see anything," says the left hemisphere. "I'll respond to the doctor though because I have the language." "I don't see anything. I can't see anything. I don't know." And this is what happens with split brain patients. If you put a ball or something on the left visual field of a split brain patient, even though their eyes physically work, their right hemisphere can see it and they can see, "Oh, I can see the object," but because it can't tell the language section, which is in the left hemisphere, what they can see and what the image is, and it can't show them, when they respond by language and the doctor says, "What do you see?" the patient literally goes, I didn't see anything. I can't see anything on the left-hand side." This is amazing. It's incredibly difficult to explain, and it's incredibly difficult to even imagine what that will look like. I do have a video later on that will illustrate this a little bit better with the patient themselves. Here are the findings describing what you see. When a picture of an object was shown to a patient's right visual field, the patient could easily describe what was seen because the language center is in the left-hand side, and that's the side that could see the image. However, if the same object was shown to the left visual field, the patient could not describe what was seen. They typically reported that there was nothing there. Language is processed in the left hemisphere. Thus, the patient's inability to describe objects in the left visual field processed in the right hemisphere was because of the lack of language centers in the right hemisphere. In the normal brain, messages from the right hemisphere would be relayed to the language centers in the left hemisphere, and therefore they would know. Split brain research. It's a series of studies which began in the 1960s and are still ongoing, involving epileptic patients who had experienced a surgical separation of the hemispheres of the brain. This allowed researchers to investigate the extent to which brain function is lateralized. So now we know that language is solely left in the left hemisphere, so it's completely lateralized. The right hemisphere literally could not say what was going on, even if they could see it. Here's a question. The drawing abilities on the left and right hemispheres. What the right hemisphere lacks in linguistic skill, it partly makes up for in terms of its superior drawing abilities. This has been shown in tests with split brain patients. A picture is flashed to either their right or their left visual field. As you can see in the drawings on the right, the left hand continually outperformed the right hand in such tests, despite the fact that for all the patients, the right hand was their preferred hand. So they would show the images, right? If they showed the image, let's get this right. If they showed, say, the image of the X, the cross, if they showed the image of the cross to their left hand side, their right visual field was not very good at drawing it. However, if they showed it to their right hemisphere, their left hand was very good at drawing it. Using your knowledge of split brain studies, explain why this shows that the right hemisphere is dominant for drawing skills. Yes. I may have explained that wrong. The left-hand side... No, I did. I explained it fine. Yeah. Using your skills of split brain studies, explain why this shows that the right hemisphere is dominant for drawing skills. You would expect right-handed people to produce better drawings with their right hand. However, for split brain patients, it is different. If they see a picture flash to their right visual field, this links to their left hemisphere and right hand. Yeah, because the left hemisphere controls the right hand, as we know. The left hemisphere is not dominant for drawing, and therefore drawings with the right hand are not as good. If they see a picture flash to the left visual field, this links to the right hemisphere and left hand. The right hemisphere is dominant for drawing, and therefore drawing with the left hand are better. If you're a split brain patient, that is. So I talk, so the left hand side talks and the right hand side draws. And that's what we found. Sweet. Identify one thing you learned about split brain studies. Why do you think learning about split brain studies is important? And this is the work that Sperry did that got him the Nobel Prize. How does split brain studies apply in real life? And what questions has split brain studies raised for you? What are you still wondering about? And identify and analyze split brain studies. We can tick that one off. Now we are on to the plenary. Right. Video. Watch this video of a patient with a split brain taking part in an experiment. So this is a replication of the experiment done by Sperry. This is an individual that had epilepsy, and they have gone through the split brain procedure, and they have severed the corpus callosum. Therefore, he has got a split brain. He is a split brain patient. Have a look at what he sees and what he doesn't see. It's interesting to see that. And there we go. There's the end of the lesson. Thank you for coming to today's lesson. Brilliant notes I'm assuming you made. Today was lesson 5, hemispheric lateralization and split brain research, right? Well done, my neuropsychologists. Great work today. Keep up the great work. I've been Mr. Neo. God bless and peace.
I'm feeling like Will, I feel like a prince, I'm feeling myself. I'm loaded with bills, cause I wasn't blessed with no Uncle Phil. Don't know how it feels. I wanted to flex, they told me to chill. I'm making a flip. My life is a flick, now load up the film.